My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are reviewing a paper titled, Regions of Intensification of Extreme Snowfall Under Future Warming. Global warming caused by persisting greenhouse gas emissions is expected to cause an increasing number of extreme weather events. The intensification of precipitation events is one of the main consequences of global warming. One of the main driving factors for this is the increase of global mean temperature of around 1 degree Celsius over the last century, and the projected future increase of a similar magnitude in the next decades. Rising temperatures lead to higher evaporation and thus enable more global precipitation. Since higher temperatures also increase atmospheric water vapor, this may lead to more intense extreme rainfall events.
That is wonderful information, Higgs. Snowfall and its extremes are a special case of precipitation, since the intensification of the hydrological cycle allows for potentially more snowfall, as long as temperatures remain sufficiently cold for snowfall to occur. These opposing forces lead to a contrast between a substantial decrease of mean snowfall and a much less pronounced decrease of extreme snow events.
That is so intriguing, Boson. With regards to snowfall, global warming has two opposing influences. Increasing humidity enables intense snowfall, whereas higher temperatures decrease the likelihood of snowfall. The researchers show an intensification of extreme snowfall across large areas of the northern hemisphere under future warming. This is robust across an ensemble of global climate models, when they are bias corrected with observational data.
What is interesting about this analysis is the following. While mean daily snowfall decreases, both the 99 and the 99.9 percentiles of daily snowfall increase in many regions in the next decades, especially for Northern America and Asia. Additionally, the average intensity of snowfall events exceeding these percentiles has experienced historically increases in many regions.
Great point, Boson. This is likely to pose a challenge to municipalities in mid to high latitudes. Overall, extreme snowfall events are likely to become an increasingly important impact of climate change in the next decades, even if they will become rarer, but not necessarily less intense, in the second half of the century.
That is a very important observation. In summary, the researchers show that there is substantial evidence that global warming and the resulting changes of the hydrological cycle may lead to intensification of daily snowfall extreme events in the coming decades.
These changes diverge between regions and the immediate and more distant future. In particular, there is a contrast between decreasing extreme snowfall percentiles in lower latitude regions like Western Europe and the higher latitude regions experiencing increasing extreme snowfall percentiles. That was an interesting paper which talked about future climate scenarios. Hope you liked it. Please follow the links to review the research in further details. Please like, share and subscribe.